In a certain country, the shorthand of a clock is exactly half as long as the longhand and rotates twice for every rotation of the longhand. The 3 points shown on the clock have accelerations of magnitude AA, AB, and AC. The point B is the midpoint of the longhand. Which of the following is true? So it seems like the only acceleration we need to worry about is the centripetal acceleration of each of these points. We know this because the hands don't have any angular acceleration because this is a clock. So there's no tangential acceleration in any of the points. So centripetal acceleration is all we need to worry about. And this is equal to the angular velocity squared times the radius. Let's find the angular velocity of B, let's say. I'm not exactly going to find it into a number, but we can call the angular velocity of B omega B. So this is equal to omega B squared times the radius of B. Now let's try to find the angular velocity of, or not the angular velocity, but the acceleration of C. Well, the acceleration of C is equal to, the angular velocity is 2 times the angular velocity of B, because in the problem it says the shorthand rotates twice for every rotation of the longhand, meaning it has to rotate twice as fast to rotate twice as much. So this angular velocity is 2 times angular velocity of B squared times the radius of B is the same because this hand is half as much as this and B is halfway through this, so RB. Or in other words, the acceleration of C, the magnitude of the acceleration is equal to 4WB squared times RB. Now let's find the acceleration of A. Well, this has the same has the same angular velocity as B because they're on the same hand. So that's just omega B squared times, instead of RB, it has to be 2 times RB since it's twice as far away from the axis. So 2 times RB. Or simplifying this is equal to 2 omega B squared times RB. So now we have the angular velocities, the acceleration of each of these in terms of omega B and RB. We know that RB is positive because the distance, like the length of the hands are positive, and we know that since the angular velocity is being squared, this also must be positive. So anything with a higher factor must be greater. So ranking this gets us, acceleration of C is the largest, and then the acceleration of A is next. Just connect that. And then finally, this has a constant of 1, a secret 1 there, so this is last. Or flipping this around, AB, then AA, then AC. So C is our answer.